Okay, so today we're going to be talking about slope. And when we're talking about slope, there's three ways that we can sort of think about slope. Okay, so we can say that slope is rise over run, which is what most of my students remember as a definition or term for slope. Okay, there's a formula that we can use for slope, which is y2 minus y1 over x2 minus x1. I'm going to write that down. Most of my students are like, oh yeah, definitely remember doing that. Okay, the third way that we can think about slope is usually the less known or maybe talked about one, which is that it's our change in y over our change in x. And while you might go, I've never heard of it that way, right? Change is our difference, which is subtraction. Okay, so they're all talking about the same idea. They're just different ways of writing them. Now, you might see this written with sort of a triangle that has a bold side on it. Maybe you've seen that in science class. It's our delta symbol. It also means change in. Okay, so if you ever see that, it is talking about the exact same thing. Now, each of these formats are sort of beneficial for a different way of looking at slope. So rise over run tends to be the most useful when we are given a graph. When we're given a coordinate plane and we have a line on it and we're trying to calculate slope. Okay, so all of these definitions, okay, are fine, but when we're looking at a graph like this, it's usually very helpful to think rise over run. Now, when we're talking about slope, we're really talking about how steep a line is. So we want to get a number that's going to tell us, is our line going uphill? Is it going downhill? Is it super steep? Is it really shallow? Okay, and so that's what we're trying to calculate. To find rise over run on a graph, we need to find two good points. Okay, you cannot just pick any random points. You need to make sure it's a good point, and it can't be close. It needs to be exact. So for example, when I'm looking at this graph, right here at 0, -2 is a good point because it goes right through at 0 and -2. Okay, but if I look over here at like 7 comma something, right, it's almost to 1, but it's not at 1. So that is not a good point. We can't use that to calculate slope because it's not a good point. Now, there are multiple good points. You just need to pick 2 of them. Okay, so for example, there's a good point over here. Okay, at -5, -4. Okay, there's a good point over here at 0, 5, at 10, 2. So it doesn't matter which 2 points you pick as long as they are good ones. Once you have those 2 good points picked, you want to count how much you have to rise, how much you have to go up, okay, to get from the level of this point to the level of this point. It's almost like an elevator. You're trying to get to the right floor. Okay, so if you're at a hotel and you're trying to get to your room, you need to go in the elevator first to get to the right floor. So from the elevator, we need to go up 1, 2 floors. Okay, then once you get off the elevator, right, how many rooms do you need to walk down? 1, 2, 3, 4, 5. Okay, so we went up 2 and we went over 5 to get to this other point. So our rise was 2, our run was 5. So rise over run, our slope is 2/5. Now you'll notice in this blank I have the letter M. The letter M we use to represent slope. Weird letter choice, but M is what we pick. Okay, now I'm making this rule right here and now, so hear it. Slope always has to be in reduced improper fraction form. So no decimals, no mixed numbers. Reduced improper fraction form is the only way that you can write slope. Okay, so let's take a look at number 2. Okay, same starting point. We need to pick 2 good points. Okay, so there's a good point at 0, 3. That one jumps out at me. I also see a good one all the way over here at 9, 0. Again, there are other good points Those just happen to be the two that I saw first. Okay, now again, you can choose to start at either point. It doesn't matter. I personally always tend to start at the lower point. But there's not a right or wrong answer. You can start either. Okay, so again, from here, what floor do we have to go to? 1, 2, 3. We need to go up 3 floors. Okay, and we need to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in the math world, this is pretty consistent, so this shouldn't be crazy. If you ever are moving down or left, you are going to use a negative number. Okay, so personally, I went up 3 and left 9. So my 9 would be negative. If you counted the other way, you'd be going down 3, right 9. So your 3 would be negative, but either way is fine. Okay, so again, my rise over my run. So my rise was 3. My run was negative 9. But this is not reduced, so that is not my final answer. I need to make sure I'm getting it reduced. So 3 over 9 reduces to 1 over 3. And I'm going to pull that negative out in front. So there's 2 ways that are going to be okay. Either your negative to be in the front or your negative to be in top. Now, I'm not going to count you wrong if you put your negative in the bottom, but remember that's not calculator friendly. So your negative out in front or your negative in top. And this is long-term what my students tend to be happier with, having that negative in the top. But recognizing that they're the same thing is good. Okay, so here's what we know at this point. Positive slope, if we look up here, look, this was positive, this was negative. Our positive went uphill, our negative went downhill. So positive slope is always going to be an uphill line. Negative slope is always going to be a downhill line. Now, a slope of 0. This is also called no slope. Right? No slope, I hope, makes sense to us that this would be flat ground. There is no slope. Okay, it's not steep, it's not slanted, there's no hill to worry about, it's flat ground. Whereas our undefined slope is going to be a vertical line, and that's when we're like falling off a cliff, right? We can't walk on a vertical line. It defies the rules of gravity, it's undefined. Okay, the next way that we can find slope is from ordered pairs. Now remember, we had options over here. Okay, so when we're looking for slope from ordered pairs, okay, the formula tends to be the best. So over here, we're wanting to do our y2 minus y1 over x2 minus x1. Now, I hope this is something you've done a lot of, so I'm not going to spend a ton of time on this one. Okay, so an ordered pair is always an x comma y. We are just going to label a first one and a second one. And then we are just going to plug into our formula. So y2 is negative 5. Now my formula tells me to put subtraction. My y1 is negative 1. So that's subtraction and negative both need to be there. Then I have x2, which is 8, minus x1, which is 2. Now remember, subtracting and negative is really adding, so use a calculator if you need to. So I get negative 4 over 6. Again, reduced improper fraction form. So this is going to become a negative 2 over 3. Number 2, same thing. I'm doing that same formula, so I'm doing my y2 minus y1. And my x2 minus x1. So this is my subtraction from the formula. That's my negative for my number. So I will get negative 10 over 0. Okay, so if we put negative 10 over 0 in our calculator, hopefully we know this, but this is not allowed. We cannot have 0 on the denominator of a fraction. Okay, this is our undefined slope. or it's our vertical line that we were talking about over here. So if we get 0 on the denominator, that's our vertical line, and we have undefined slope. Okay, number 3, we're doing 4 minus -3 over -5 minus -7. Again, those two negatives are making a positive. We get 7 over 2. That is reduced. Do not turn that into a mixed number. So 7 over 2 is our final answer there. Number 4, we have -6 minus -6 over -3 minus 4. Okay, so now we have 0 on top. And when we get 0 on top, we're doing 0 divided by -7. Okay, and 0 divided by -7 is 0. Okay, so this is our slope of 0. We could write the number 0. We could say 0 slope, or we could say no slope. And that is our horizontal line. Sorry, couldn't find the word there in my brain. Okay, so this is going to be our horizontal line. Last thing here is our rate of change. Now, rate of change is just slope, so don't feel overwhelmed by this. We are finding slope. The only difference here is that it's slope that gets a label. Okay, we want to label what's happening. It's that same idea as the unit rate that you start talking about in like 6th grade. So you've been doing this for quite a while too. The easiest way to do rate of change is that last option that we looked at in our notes, and that's our change in y over our change in x, and we're just going to give it a label. Now, A, you could decide when you look at this, you could say, okay, I just want to write this as 2 ordered pairs. And I just want to write this as 3, 6 and 5, 10. And I want to find the slope just like I did up above. There's nothing wrong with that. Okay, so if you decide you don't want to do anything new, that's fine. If you do just want to stick to the table, you're going to ask yourself, what do I have to do to 6 to get to 10? It's always in the addition and subtraction world. Don't think multiplication. Okay, so there I'm going to add 4. And what do I do over here? I add 2. Remember rise, so the y over the x. So I'll get 4 over 2. Again, I'm going to reduce that, which is 2. Now, the label tends to freak my students out. Take a deep breath. It's just our y per our x. It's our cost per pound. Now, normally we wouldn't write it as a fraction, so we'll say 2 is our cost per pound. If we knew that this was dollars, remember this is how we abbreviate pound, we would say $2 per pound, but we don't know that that's what it is. I have no idea why, but guys, somehow I deleted this. So we're just going to use different points because it doesn't matter what 2 points you pick. So maybe you pick here and here just for funsies. We're going to try and pick a different place. It's still the same idea. What would we do to get from 19 to 23? We add 4. What do we get from 7 to 9? We add 2. Again, as long as we reduce, we'll get the same answer. This one will be our cost per hour.